hour. Today we're going to cover the exam 3 review. I know some of you guys already took the exam last week, but hopefully this will help some of the students that have not taken the exam yet, which will probably be this week also. Okay, these are the topics that I'm going to cover. This is all from chapter 6. Um, let's start out with 6.1, which are systems of two linear equations and two variables. And then afterwards, it'll be larger systems of linear equations, applications of systems of linear equations, basic matrix operations, matrix products and inverses, and finally, applications of matrices. Let's start with section 6.1. For this one, number one, it says determine whether the given order list of numbers is a solution of the system of equations. So let's call this equation 1 and equation 2. Okay, we gotta verify that this point negative 1, 3 is a solution for these two linear equations. So what we do, we're gonna plug in negative 1 for x and 3 for y for both of the equations. So in equation 1, we have 2x plus y equals 1. So we're gonna plug in the negative 1 for x and 3 for y. Right, after we evaluate the left side, this will give us negative 2 plus 3, which is equal to 1. So 1 equals to 1, so this is true, correct? But remember, the point has to be true for both equations. So we already did the first one, now let's do the second one. We're going to repeat the process, and we're going to plug in negative 1 for x and 3 for y. Okay, we're going to evaluate the left side. So this will give us 3 plus 6. This will give us 9 equals 9. That means that this point is a solution to the systems of equations. Now for number 2, we're going to repeat the same process, but we have a different point and different equations. We're going to plug in 2 for x and negative 0.5 for y. Okay, again, this is equation 1, the first one, and equation 2 will be the second one. So let's do equation 1 first. I'm going to plug in 2 for x and negative 0.5 for y. After we evaluate the left side, it's going to give us 1 minus 4 equals negative 3. So the left side is equal to negative 3, which makes it true. So negative 3 equals negative 3. So that means that this is true for the first equation. Now we proceed for the second equation, and we repeat the process again. So x is 2, and y is negative 0.5. After we evaluate it, the left side is going to give us 2 minus 2.5, which the result on the left side will give us negative 0.5, and on the right side is negative 5. This is not true because they're not equal to each other. That means that this point is not a solution to the systems of equations. So number 1 was yes, and number 2 was no. Okay, not a solution. Now let's solve a system by graphing. I know that graphing is not part of part of the section here, but I just wanted to include it because you can solve systems by graphing, substitution, elimination method, and also by matrix. So I'm going to show you the very same two equations. We're going to graph them to find a solution, and then we're going to use substitution, and then we're going to use the elimination method. This is to let the students know that you can use any method, what's easier for you guys. Okay, on equation 1, we have y equals to 3x minus 6. This is something that you guys should know by now. This is from chapter, I believe, chapter 2 of this semester. So my slope is 3 over 1. And my b is a y-intercept, which is 0, negative 6. And this is my starting point, 0, negative 6. So I'm going to start at 0, negative 6. I'm going to go to my grid. So I'm going to go down on the y-axis to negative 6. Then the slope is 3 over 1, right? Which is positive, which means it's going to go up 3, 1, 2, 3, and 1 to the right. Apply my point. Now I connect the 2 points, and that's my line. Now I'm going to graph equation number 2. Equation number 2, you can do it by using finding the x and y intercept. But let's keep it in the same format as number 1. So I'm going to put it, rewrite it in the slope intercept form, which is y equals to mx plus b. So I'm going to add 5x to both sides. Right, so it's going to give us negative 2y equals to 5x minus 10. I divide both sides by -2. And the result is y equals to -5/2x plus 5. Now what's my slope? My slope is -5/2. And my y-intercept, which is a b, is equal to 5. So the y-intercept is 0, 5, and this is my starting point, the 0, 5. So I'm going to go back to the grid. I'm going to plot 0, 5, which is in the y-axis. It's here at +5. And then the slope is -5/2, which means I'm going to go down 5 and 2 to the right. From where? From the b value, which is 0, 5. So I'm going to go down 5. Let's see, 1, 2, 3, 4, 5, and 2 to the right. 1, 2. Now I'm going to connect the 2 points, and that's my line. If you notice, the lines intersected at 2, 0. So that's my solution. The solution is 2, 0. Now I'm going to use another method to solve the same system, right? Again, I did it by graphing, which was 2, 0. Now let's do it by substitution. So since I'm going to call the equation the first equation number 1 and the second equation number 2. So this is a plan here. When you're solving by substitution, you're going to have to isolate either the x or the y, and then plug it into the second equation. In this case, if we notice, the y on equation number 1 is already isolated. So it's easier to go to my second equation and plug in 3x minus 6 where the y is. Okay, and I use color-coded so you can see exactly where it's going into. So the y is 3x minus 6. Now here I use the distributive property. Distribute, right? And then now this will give us a -5x. -2 times 3x will give us -6x. -2 times -6 will give us a +12. So now we can combine like terms. The -5x and -6x, they're called like terms. So we can add them or subtract them. In this case, we're going to add them and keep the sign of the negative number, right? So it's going to be -11. -11 plus 12 equals -10. Now I have to isolate the x, so I'm going to subtract 12 from both sides. They'll give us -11x equals to -22. My next step is I'm going to divide by -11. So x equals to 2. Now you can either go back to either 1 or 2. Equation 1 or 2 and plug in the value for x, which is 2, on either equation. Whatever is easier for you. In my case, I'm going to go back and use equation 1 because the y is already isolated. So I'm going to plug in 2 for the x's. So it'll be 3 times 2 minus 6. So it'll be 6 minus 6. The answer is 0. Y is 0. So what's my solution? 2, 0. You see here we get the same thing. Okay? Okay, now here, I was going to do it again but you can do it this way too by solving by using the elimination method. Okay, but for the sake of doing more examples, I'm going to use a different system here. Now we're going to solve it by substitution. I mean by the elimination method. I'm sorry. Again, the first equation I call it equation 1, and the second equation I call it equation 2. Using the elimination method, both equations must be in the form of ax plus by equals c. If you notice, equation 1 is not in proper form, so I need to rewrite equation 1. So I'm going to add 2y to both sides. So we have x plus 2y equals to 19. Now it's in proper form. That's my rearranged equation 1 and equation 2. Here, I believe I'm going to get rid of here it doesn't matter what you get rid of, the x's or the y's. In my opinion, it's easier to get rid of the x's, right? Why? Because this, I need to multiply the first equation by -4. Why -4? Because we want the x on the first equation to be -4x. This way, when we add them, the x's will be eliminated. But I have to multiply the -4 times both sides of the equal sign. Right, so -4 times x will give us -4x. -4 negative 4 times positive 2y will give us 8y. I mean, negative 2y, this will give us what? Negative 76. Now, equation number 2, all we do is slide it over. Now we can combine the I mean, here the x's, right? They're going to be eliminated. And for the y's, we have negative 8y minus 3y will give us negative 11y equals to negative 77. Now to solve for y, we divide both sides by negative 11. So y equals to 7. Now I need to find the x value. So I can either go to equation 1 or 2. And again, what's easier for me will be go to equation 1 here at the top. The x equals to negative 2y plus 19. So I'm going to plug in 7 for the y. So we have negative 14 plus 19, which will give us 5. So when x is 5, the y is 7. So this is my solution, 5, 7. Again, solve the system by elimination. Okay, let's solve this one now. Here, to get rid of the x's, we have to multiply the first equation by negative 2. Okay, now I need to multiply negative 2 times both sides of the equal sign or times every term. This will give us negative 6x plus 4y equals to negative 8. And equation 2, we just slide it over. You notice everything was eliminated. So we got 0 equals to 0. So this means it's going to be infinite solutions. That's your result. Now result number 7. Again, we're doing by the elimination method. So I'm going to multiply negative 3 times equation number 1. Why negative 3? Because negative 3 times 2 will give times 2x will give us negative 6x. Then when we add them, the x's will be eliminated. The result will give us negative 6x minus 15y equals to negative 24. Equation 2, we'll just bring it over. Now if we add them, it's going to give us 0 equals to negative 6. Is this true? No. That means that there's no solution, which means the lines are parallel. They will never intersect. Let me go back real quick. You see, so the lines, these two lines are parallel. That means no solution. Okay, now how do we apply these type of problems in the real world? Okay, here's a good example. It says, this is number 8. A 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So what's the solution here? We need to find two equations. And then we can solve them by substitution, by graphing, or elimination method. The easiest way will be the elimination method. So here we're going to do seats with seats and money with money. For example, since adult was first, I'm going to let x equals to the adults. I'm going to let y equal to the children's seats. And the total number of seats was 200. That's why it's going to be seats with seats. The total was 200. So this is equation number 1. X plus y equals to 200. Now let's find equation number 2. If the money was $8 for adults, right? Since adult is represented by x, this will give us 8x. Now it was $5 for children, right? Since y represents children's seats, then this is going to be 5y. And what was the total revenue or total income? Was $1,435. So now this is my equation number 2. It's going to be 8x plus 5y equals to 1,435. We have both equations now. Again, equation 1 and 2. Now here we can use the elimination method to solve for the x and the y, which the x is the adult tickets and the y are the children's tickets. So I'm going to get rid of the And when you eliminate the x's, we're going to multiply the first row by negative 8. Negative 8 times x will give us negative 8x. Negative 8 times y will give us negative 8y. And negative 8 times 200 will give us negative 1600. Equation number 2, all we do is bring it over. Now we get to Adam. And you notice the x's will be eliminated. We got negative 3y equals to a negative 165. Divide both sides by negative 3. The result is y equals 55. Now I need to find the x value. So again, I need to go back to either equations 1 or 2 and plug in the value for y, which is 55, on the y of the equation that you choose, and solve for the x. Again, my opinion is easier to use equation number 1. My y is 55, so I'm going to plug it in. Now we're going to solve for x. We subtract 55 from both sides, and x equals to 145. My x is 145 and my y is 55, but they're asking about how many adults and how many children were in the audience. So we have to go back, and since we use x for adults, the answer will be 145 adults and 55 children. This is the answer that they're looking for. Okay, now let's move on to section 6.2, which is also part of the exam review. 6.2 is larger systems of linear equations. Okay. Say this is the example that I'm going to work on. Again, here we're going to have 3 equations. Each one of these equations has x, y, and z equals to a constant. So here I'm going to show you like a plan that you can never go wrong if you apply this plan. I'm going to use equations 1 and 2 and get rid of the x's. Okay, so that's the plan. I'm going to use equations 1 and 2, get rid of the x's, and then use equations 1 and 3 and get rid of the x's. Okay, so let's see here. So we're going to use the elimination method. So equation 1, I'm going to multiply by negative 2. I need to multiply negative 2 times every term on equation number 1. The result will give us negative 2x plus 6y minus 4z equals to 0. Equation number 2, all we do is slide it over. Then we add them. They will give us 4y minus 3z equals 3. This is a new equation 2. Now we're going to repeat the process, but we're going to use equations 1 and 3. And again, I'm going to get rid of the x's, so I need to multiply equation 1 by negative 3. Negative 3x plus 9y minus 6z equals 0 is a result of multiplying negative 3 times equation 1. Now equation 2, all we do is bring it over. Now we combine, we add them. It will give us 0. 10y minus 7z equals to 7. Well, that's my new equation number 3. Now the next plan is we use the new equation 2 and the new equation 3, and we're going to get rid of the y's. So now here, the least common multiple is 20. But a lot of students, they don't know about the least common multiple for both the 4 and the 10. But the way I like to tell my students to do it is just to, forget about the least common multiple. Instead, I'm going to multiply, since they're both positive, right? And we want to get rid of the y's. I'm going to multiply the first equation by negative 10. And the second equation by 4. This will guarantee me that the y's will be eliminated. So now I need to multiply negative 10 times every term on equation 2. That will give us negative 40y plus 30z equals to negative 30. Now we multiply 4 times every term on equation 3. That will give us what? 40y minus 28z equals to 28. Now we add them. The y's will be eliminated. So we're going to get 2z equals to negative 2. Now to solve for z, we have to divide by 2, both sides by 2. After we do that, we have the result for z. Z equals to negative 1. But remember, the answer or the solution has an x, a y, and a z. I already found the z, so now I need to find the y. So for the y, I'm going to go back to either equations 1 or 2 and plug in the value for z on the z, and then we solve for y. So I believe I'm going to go to equation number 2 because it seems, I mean equation 1 because it seems easier because the numbers are smaller. Okay. And then after do that on equation 1, I'll go back. I mean, after I plug in the value for z on equation here on equation 2, then I'm going to plug in the value for z and the value for y that we get on equation 1 to solve this in the system. So I'm going to go back to number 2. I'm going to plug in -1 for z. Now get to evaluate. They will give us for y plus 3 equals 3. We subtract 3 from both sides. So we got for y equals 0. Divide both sides by 4. So y equals to 0. I found my z and I found my y. Now I need to find x. So I'm going to go back and plug both values for y and z into equation number 1. So the y is 0 and the z is -1. It will give us x minus 2 equals 0. X equals to 2. So I found the solution to the system. It's going to be 2, 0, -1. That's my solution. Now, this is a Gauss-Jordan elimination method. This method is crucial for the students that are taking 1325, which is the next math course after 1324. The section that this is going to be covered, I believe it's in the next, what is it, chapter, I think chapter 7. I mean, for this book, the one that we're using here. But it's up to the instructor if he wants to cover, I think there's only two sections, 7.1 and 7.2. It's up to the instructor if they want to cover it. Most instructors here, they don't cover it at EPCC, but I mean, some do, but at UTEP, they all do. So this, you should know or have an idea how to work it because you'll be seeing it again, either here or UTEP or any university, you're going to be seeing this method again. Okay? So I'm going to show you the plan, how to come up with the answer. This is linear systems of equations. This is called augmented matrix. And then we're going to go to reduced row echelon form. That's what the RREF stands for. And I'm also going to show you how to put it in the calculator later on this PowerPoint. Okay, now, you see this is a system, all right? Systems of linear equations. Now to put it in augmented matrix, this becomes my first row, second row, and third row. You see my first row, all we do is get the coefficients. This is 1, -3, and 2, and then 0. So for the second row, it's going to be 2, -2, 1, 3. And for the third row, it's going to be 3, 1, -1, and 7. This is called the augmenting matrix. Now, for it to be a reduced row echelon form, this is how it should look. All these are ones diagonally, and the rest are zeros, which means the first column are the x's, the second column are the y's, the third column are the z's, and this is the solutions. Okay? So on the first row, this is the same thing as saying 1x plus 0y plus 0z equals to 2. In other words, x equals 2. On the second row, right, the value for the 1 is under the y's column, so this is the same thing as y equals to 0. And for the third row, it's the same thing as z equals to -1. Okay, but I'm going to show you how it's done. I call it the three-step plan in action. Okay, now, the first step, right, this will be my answer for this one here. If you put in the calculator, this will be the result. Isn't that what we got? 2, 0, -1. Okay, anyway, this is the same one that we worked earlier, okay? But now we're going to do the solve it by using matrix, the Gauss-Jordan method. This is row 1, row 2, right? I'm going in from here, and this is row 3. So the first step, right? The first step, you see, they also color coded, so students can actually visualize what we got to do. The first step, the two white on the first column, the 2 and the 3 must be zeros. So for the first step, we're going to use equation 1 to get rid of the 2 and the 3 on the first column, on the second row and third row, here where the mouse is pointing at. So row 2 is going to change. You see, I mean, I must have put them in blue there. The 2 and the 3 must change, right? So row 2 is going to change. And now, so the 3 where the third row is got to change too. So the rows 2 and 3 they have to change, because going back here on top, they have to be zeros. So now I'll be using row number 1. So if you notice, we have a 1 here, and we have a 2 here. So the value here for the 1, it has to be a -2. Why -2? Because -2 plus 2 will give me a 0 where the 2 is right here in blue. So I'm going to multiply -2 row 1 and add it to row 2. And also where the 3 is on the first column, third row, it has to be a 0 also. But I'm going to use row 1. So I'm going to multiply -3 row 1 and add it to row 3. And here's my work. -2 row 1 is equal to -2, right? So I'm going to distribute the -2 times times a 1, -3, 2, and 0. So this will give us, like, -2 times 1 is -2. -2 times -3 will give us +6. -2 times 2 will give us a -4. And -2 times 0 will give us a 0. And row 2, all we do is bring it over, which will give us 2, -2, 1, 3, right? This is row 2 here. Now we add them. You see the on the first column, second row, it became a 0, because -2 plus 2 will be 0. 6 minus 2 is 4. -4 plus 1 is -3. And 0 plus 3 is 3. So that's my new row 2. Now let's do the second part of step 1. -3 row 1 is equal to -3 times row 1, which is 1, -3, 2, and 0. So after I multiply the -3 times row 1, this is my result. -3, 9, -6, and 0. We're going to add it to row 3. So row 3, all we do is bring it over, which is 3, 1, -1, 7. Then we get to add them. This will give us 0, 10, -7, and 7. So that's my new row 3. Okay, now I'm going to continue row 2 on the next slide. So I'm going to carry just this part over to the next slide and start, the step 2. Okay, now. So step 2, if you notice, here on top is the one in green, which means this -3 has to be a 0, and the 10 has to be a 0. So for step 2, right, I'm going to keep row 2. So now the -3 must be a 0, so row 1's got to change. And the 10 must be also a 0, so row 3's got to change. Okay, now here, right, to eliminate the -3, right, where the spot is, I'm going to multiply 3 times row 2 and add it to 4 row 1. Okay. Over here, to eliminate the 10, I'm going to multiply -10 times row 2 and add it to 4 row 3. And here's my work. 3 row 2 is the same thing as multiplying 3 times row 2, which is 0, 4, -3, and 3. That's my result from multiplying 3 times row 2. Now we're going to add it to 4 row 1. So 4 times row 1 is 4 times row 1 is 1, -3, 2, 0. That's what I have here with the parentheses. So after I distribute, right, it's going to give us 4, -12, 8, and 0. After we add them, if you notice, the 12s will be eliminated, which is on the y column. So that becomes my new row 1. Now the work for the second part of step 2 is -10 row 2, which is -10 times row 2. That'll give us 0, -40, 30, and -30. And we're going to add it to 4 row 3. That'll give us 0, 40, -28, and 28. After we add them, we get 0, 0, 2, negative 2. It's always wise to simplify as you go along. By that I mean, if you don't get a fraction, then you simplify. For example, on this situation, I'm going to divide 2 times every term here. This will give us 0, 0, 1, and negative 1. That's my new simplified version of solving for the third equation on step 2. Because this, if you try to have ones here, it'll make the work easier. But if you, say here on the last column, if that was like a 3 or negative 3, you don't divide by 2 because you're going to get a fraction. And this method, you eliminate all the fractions until the very end. Okay. Anyway, I'm going to continue the next slide. Step 3. So step 3, I put it in red. So step 3, we're going to keep row 3. And for the negative 3 is going to be a 0. And also the negative 1 must be a 0. So rows 1 and 2 must change. Okay, we're going to use row 3. So as we notice, row 1, where the 1 is already negative, and the 1 here at row 3 is already positive. So here, all I'm going to do is add row 3 plus row 1. And to eliminate the negative 3 on the second row, I'm going to multiply row 3 plus row 2. And here's my work. Row 3 plus row 1 will give us 4, 0, 0, 8. And like I mentioned earlier, if you simplify as you go along, the work will be much easier and you don't have to do that many matrices. So we divide by 4. So we get 1, 0, 0, 2. That's my new row 1. For the second part of step 3, I'm going to multiply 3 times row 3, which will give us 0, 0, 3, negative 3. And add it to row 2, right? It's going to give us 0, 4, 0, 0. We divide everything by 4 because we want a 1 in that place. So it's going to give us 0, 1, 0, 0. That's my new row 2. If you notice, we completed right. The objective was to make all the diagonals 1s and the rest 0s, which we did. So here's my solution. Will be 2, 0, negative 1. That's your answer. Okay, now let's solve this one. Let's do one more, okay? But we already know the plan. I leave it like this, guys, because if you guys want to download the PowerPoint, you can there at the beginning. And since I'm sharing my screen, I cannot point to what I'm talking about. But when we go back to the main page, you'll be able to download the PowerPoint. And then this way, you guys can practice here, and it shows you step by step what to do. For example, these PowerPoints I uploaded for my students on Blackboard. After I explain the concept, they're required to go back and try to understand it. That way they can understand how to solve the system by using the Gauss-Jordan method. So perhaps you guys can do the same thing. Okay. So anyway, step 1. Step 1, we're going to keep row 1. So we're going to change row 2. I'm going to change row 3. So on the first column, where the 2 is on row 2, that must be a 0. And also the first column for the row 3 is, that has to be a 0. So I'm going to use row 1. To get rid of the 2, right, we have to multiply negative 2 times row 1. That way the 2's on the first column, the second row will be eliminated. So it's going to be negative 2 row 1 plus row 2. And if we notice, the 1 here on row 1 on the first column, and also the negative 1 here on the first third rows, first column, you see we add them, they'll be eliminated. So it's going to be row 1 plus row 3. And here's the work. Right, negative 2 row 1 plus row 2. This will give us negative 2 times 1, 2, negative 1, 6 will give us negative 2, negative 4, 2, and negative 12. And we add it to row 2, right? Row 2, all we do is bring it over. It's going to be 2, negative 1, 3, 2. After we add them, right, it's going to be 0, negative 5, 5, and negative 10. If you notice, here we can simplify. Why? Because we can divide everything by negative 5. This way, it requires less matrices, and also the work will be much simpler. Okay, so this is my new row 2. Now let's do the second part for step 1. Row 1 plus row 3 is going to give us 0, 1, 0, 1. That's my new row 3. Now step 2, we're gonna keep row 2 how it is. Okay, the 2 on the first row, second column, has to be a 0, and the 1 on third row, second column, that must be a 0. So I'm going to change row 1, and I'm going to change row 3. So by using the 1 on the second column, row 2, I need to use that to get rid of the 2 on top here. So this is what I'm going to do. I'm going to multiply negative 2 times row 2 and add it to row 1. And for the second part on step 2, I'm going to multiply negative 1 times row 2 and add it to row 3. Here's my work. Negative 2 times row 2 will give us 0, negative 2, 2, negative 4. Plus row 1, so we're going to slide row 1 over. Then after we add them, it's going to give us 1, 0, 1, 2. That's my new row 1. Now negative 1 row 2 will give us 0, 1, negative 1, 1, and negative 2. Plus row 3, all we do is bring row 3 over. After we add them, it's going to give us 0, 0, 1, and negative 1. That's my new row 3. And we notice we're almost there, because now the third step, these 2 ones on the third column must be eliminated, which is the first one on the first row and the second row, third column. So step 3, we're going to keep row 3, because that's the one that we're going to be using. So row 1's got to change, and row 2's got to change. So here, right? So by using the third row to get rid of the 1 here on the first row, I multiply negative 1 times row 3 and add it to row 1. And to eliminate the second row, third column, the negative 1, we just add these 2. So it'll be row 3 plus row 2. And again, here's my work. Negative 1 row 3 will be negative 1 times 0, 0, 1, and negative 1. And here's my result. It's going to give us 0, 0, negative 1, and 1. We're going to add it to row 1. Row 1 is 1, 0, 1, 2. After we add these, it's going to give us 1, 0, 0, 3. That's my new row 1. So for the last part, on step 3, we're going to add row 3 plus row 2. After we execute the operation here, we're going to give us 0, 1, 0, 1. That's my new row 2. You notice we're done with the objective, right? All these are 1s diagonally, and the rest are 0s. That means this is my solution. It's going to give us x equals to 3, y equals to 1, and z equals to negative 1. That's my answer. Okay, now, how does this apply like in word problems here? Okay, so tickets, this is the word problem number 12. Tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert, and the total ticket receipts were 1,150. Three-fourths as many teenagers as preteens attended. How many adults, teenagers, and preteens attended? We need to find 3 equations. Again, we're going to do people with people and money with money. And the third equation will be the second to last sentence on this little scenario here. So we're going to since adults are first, that's going to be my x. Since teenagers are second, that's going to be my y. Since preteens are third, that's going to be my z. So there's x number of adults, y number of teenagers, and z number of preteens. And the total people in the concert were 570. So my first equation is x plus y plus z equals to 570. Now, for the second equation, right, the adult tickets cost $5. Since x represents adults, it will give us 5x. Teenager tickets are $3. Since y represents teenagers, so this is going to give us 3y. And since the tickets for preteens is $2, and since z represents preteens, so this is going to give us 2z. And finally, what's the total revenue or the total money receipts is 1,150. So here's my second equation: 5x plus 3y plus 2z equals to 1950. I got the first two equations, but we're looking for the third one. Need equation number 3. Now, the second to our last sentence is how we find equation number 3. Okay, now, it says here 3/4 as many teenagers as preteens attended. Okay, now here's my setup. So this is going to be y equals to 3/4z. At times, students might wonder, how in the world did you get that, or how did you know it was like that? Okay, I tell my students, if it's difficult, write it how it sounds, and then switch it. I think switch it is, hopefully that's the right word, okay? But in the past, I used to say flip it, and I knew it was the wrong word to use, but let me show you what I'm talking about. Doesn't it sound 3/4 teenagers, right? 3/4 y, and y is teenagers, equals to preteens, right? That's the way it sounds. But in reality, the 3/4 must go with a z, right? That's why I said switch it. That's your setup right there. But now, I have to put it in the form of ax plus by plus cz equals to d, which means the z has to be on the left side. But most of the times, we don't want fractions, so we're going to multiply both sides by 4 to eliminate the fraction. Now we're going to subtract 3z, and I found my third equation. They're my equations, okay? Now we get to solve them, right? I'm going to use one, the way we did it. You can do it by matrix, but matrix is kind of a little bit more challenging. That's why I did it the old way, right? We're going to get rid of the x's, so multiply by -5. They will give us -5x minus 5y minus 5z equals to -2,850. Right, so we just bring the equation 2 over. It's going to give us -2y minus 3z equals to -900. Now I'm going to get equation, right, for the second part, right? Since there's no x on equation 3, so we can skip that part. So this is my new equation 2, the one that we just solved by getting rid of the x's. And 3, how it is here, will be my equation 3. Now here I'm going to get rid of the y's. So equation 1, I need to multiply by 2. Again, why 2? Because 2 times -2y will give us -4y. Then when added to equation 3, the y's will be eliminated. Okay, we just bring equation 3 over. We add them. So -9z equals to -1,800 divided by -9. The result, z, is 200. Now we go back substitute. Okay, here on equation 2, I could have gone equation 3 here because it's the same thing, or the one that we solved for by eliminating the x's. So here you can use either one. So let's go back to equation 2 and substitute. We know that z is equal to 200. So I'm going to plug it in there for the z. It will give us -2y minus 600 equals to -900. We add 600 to both sides. That gives us -2y equals to -300. We divide both sides by -2. The answer will be 150. So I have my x, and now I need to find x. I got my y, and I got my z. Now we plug them in to equation number 1. The y is 150. The z is 200. This gives us x plus 350 equals to 570. We subtract 350 from both sides. and the result will give us 220. So I found the solutions, but remember, X was adults, Y was teenagers, and Z was preteens. So this is the answer. Let me go back real quick. There were 220 adults, 150 teenagers, and 200 preteens in attendance. Now we're going to do matrix addition. Okay, for addition and subtraction, in order for you to add them or subtract them, they have to be the same size of matrix. That's why this is a 2 by 3, a 2 by 3 for B. C and D are 2 by 2s. So A plus B is the same thing as 5 plus 2, negative 1 plus 0, 6 plus 1, 3 plus negative 3, 4 plus 1, and negative 2 plus 4. That's going to give us 7, negative 1, 7, 0, 5, and 2. That's my solution. Let's do C plus D, right? And again, C and D are the same size, so we can do the operation. So it's going to be 3 plus 2, 1 plus negative 1, negative 5 plus 8, and 0 plus negative 6. And the result will give us 5, 0, 3, and negative 6. That's my solution. How about C plus A, right? We know that C is a 2 by 2. We know A is a 2 by 3, so this cannot be done because the matrix are not the same size. Okay. Now subtraction is the same way for subtraction. Okay. Again, these are the same matrices than before, but instead of adding, we're going to subtract them. A minus B will be the same thing as 1 minus 8, negative 3 minus 0, 2 minus 1, 2 minus negative 1, 2 minus 3, and negative 1 minus 4. The result will give us negative 7, negative 3, 1, 3, negative 1, and negative 5. That's my solution. Now let's repeat the process with as before, but it's going to be C minus D instead of adding. So it's going to be 5 minus 2, 1 minus negative 1, negative 4 minus 9, and 3 minus negative 7. The result will give us 3, 2, negative 13, and positive 10. That's my result. Again, A minus C is not possible because they're not the same size. The A is a 2 by 3 and the C is a 2 by 2. Now comes multiplication. Okay, here we're going to be multiplying and adding, and not multiplying by a constant or by a scalar. So negative 4A is the same thing as negative 4 times every element in matrix A. Same thing as negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. This will give us 8, 0, negative 20, and negative 12. I can go straight from here, from the setup to the answer. This is just the second step is to show you what was taking place. Okay. Now 5B, 5 times B. There's 5, there's my matrix B, and we're going to do the same thing, 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. The result is 0, 10, 20, and negative 30. Now let's do part C. We're going to do negative 4A plus 5B. The first part, negative 4A, we did it in part A, so we'll just bring it over. Right? It's in blue here. Plus 5B, we did the 5B in part B, which we just bring it over, right? Which is in red, color in red. Now we add them. So it's going to be 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. The result will be 8, 10, 0, and negative 42. That's my answer. Can you see we got about 8 more minutes? Now, multiplying. Multiplying has to have a special condition here. They can be also the same size like a square matrix is. But here, guys, what matters is that when you write the matrix, right, these must match. The two in the middle must match. For example, since B is first, B is a 2 by 2 matrix. And says matrix A, right? So it'll be, yes, we can do it here. It's a 2 by 2, and the answer will be a 2 by 3. So it can be done. So the answer will be a 2 by 3. Okay, now this will be like this is the way the book shows you. Okay, now so if you need help on my math lab, this is the way they show you. So I'm going to put the first matrix and the second one, right? If you notice, these are the colors, and blue and then red. That means I'm going to multiply 1 times 2 and 0 times 4. We're going to add them. It'll give us 2 plus 0. The answer is 2. So the 2 goes on the first lot here. Now for step 2, I'm going to continue, right? But now I'm going to multiply the first row times the second column. That's why the second column will be in red. Now multiply 1 times 0 will give us 0. 0 times -2 will give us 0. So 0 plus 0 will give us 0. So the 0 goes right here on the first row, second column. Now step 3, we need to multiply by the last column here, right? So the last column will be in red. That way you guys can see exactly what's taking place. 1 times 5 is 5. 0 times -3 is 0. So 5 plus 0 is give us 5. So 5 goes on the first row, third column. Right, so we're done with our first row times every column. Now we're going to use the second row and repeat the process, multiplying times the first column, second column, and third column. So here first, it's going to be 4 times 2 is 8. -2 times 4 is -8. So when we add them, they'll cancel, right? There'll be 0. So the 0 goes on the second row, first column. Now step 5. You're going to multiply the second row, again, times the second column. 4 times 0 is 0. -2 times -2 is 4. So this will give us +4. So the 4 goes on the second row, second column. And finally, we multiply the second row times the last column. 4 times 5 is 20. -2 times -3 is 6. 20 plus 6 will give us 26. That's my solution. Okay. Okay, now let's see here. Finding the inverse. Let me see how we're doing on time. Yeah, we're doing okay. So the inverse, there's like 2 ways to do it. Okay, this is by using the Gauss-Jordan method. If you notice, this is called the identity of a 2 by 2 matrix. 1, 0, 0, 1. Now, we're going to use the Gauss-Jordan method from 6.2, and this is what the answer should be like. That means the identity must come all the way to the left, and whatever's on the right, this will be your inverse. So I'm going to show you 2 ways how to find the inverse of a 2 by 2 matrix. Okay. Okay, now, so again, right? So I'm going to use, this has to be a 0. For the 4, it has to be a 0. So I'm going to multiply -4, row 1, and add it to row 2. Okay. We're going to keep row 1. So here's my operation here. So it's going to give us -4. It's going to give us -4, -8, -4, and 0, because multiplying -4 times all these digits will result in -4, -8, -4, and 0. Now the row 2, I will do is slide it over. So after we do the operation, it's going to give us 0, -4, 0, -2, -4, and 1. That's my new equation number 2. Now, for the second step, with a -2 here, I'm going to have to get rid of the 2 there on the first row, second column. So I'm going to add row 2 plus row 1. So we keep row 2. So here's the work, right? We're going to add them. You're going to give us 1, 0, 3, -3, 1. That's my new row number 1. Okay, now if you notice, this part, the first column is okay because we have 1 and a 0. But here on the second column, where the -2 is, has to be a 1. So I'm going to multiply the second row by -1/2. Now here's my inverse, because negative 1/2 times 0 will give us 0. Negative 1/2 times negative 2 will give us 1. Negative 1/2 times negative 4 will give us 2. Negative 1/2 times 1 will give us negative 1/2. So this is my inverse here on the right side. Okay. Now there's another way to find the inverse. If that was kind of a little bit challenging for you, this is much, I believe, easier. Here's a formula. To find the inverse, it's going to be 1 over A times D minus B times C. If you notice, the A is, I'm going to multiply here diagonally, A times D minus B times C. I think this is called a determinant. And then we switch the A and the D, and the B and the C, we switch the signs. Okay? Here we go. The same one as before. So it's going to be 1 times 6 minus 2 times 4. Now here, the 1 and the 6 switch places, right? That's the A and the D switch places. And where the B is and the 4 is, you change the signs. Okay? So here on the bottom, we have 6 minus 8 is negative 1/2. So I'm going to multiply the scalar negative 1/2 times every element in the matrix. That will give us what? Negative 3, 1. Negative 1/2 times negative 4 will give us 2, and negative 1/2 times 1 will give us negative 1/2. So this is my solution. Let me go back. And if you notice, it's the same solution as when we did it the other way by using the Gauss-Jordan method. Now here's how you plug in the calculator, guys, okay? But this, I'm going to go a little bit quick for the sake of time. Okay? You're going to hit second matrix. Then you're going to go to this key here. Then you're going to go to edit. You're going to enter the size of the matrix. And after the size, you're going to enter every entry. You're going to go to second quit, and when you do this, the screen should be blank. Okay. Now the matrix will be saved there. Now here in solving, you're going to go again. You're going to go to second matrix again. You're going to go to math, and then you're going to go down to RREF. And you're going to enter it. And after you do that, this is what it gives you. Then you choose the matrix being solved, and then you close up parentheses. And then enter, and it's going to give you the answer. Okay? If the matrix was a 2 by 3, right? Then this is the way it should look like. If the matrix was a 3 by 4, then it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you're going to have A, B, and C here on the side. These are the solutions here, guys. Okay, now, I know I went by it a little bit fast because it's almost time, and I think I need like 2 more slides to go. Okay, now, if you want to, so the matrix and the calculator, you can stop, right? But if you repeat the process by beginning to add additional matrix. You can go, I think you can go all the way to 8 or 9 matrices there in the calculator. And then you can use them to do the operations. Okay. Okay, now solve the matrix equation by using the AX equals to B. Solution. X equals to the inverse of A times B. Why? Because to solve to cancel the A, we got to get the inverse to both sides. That's why if we do the inverse to both sides, we get X equals to the inverse of A times B. Okay? Using the inverse formula for the 2 by 2 matrix, right? I mean, to get the inverse of A. Right? If we use that formula, this is what we should be, right? The inverse will be, that's my inverse. I didn't show the work because I did it in the previous slide. Now, my X, right? I'm going to multiply the inverse of A times B, so I'm going to multiply the inverse times B times the negative 3, 5. And again, right? So I'm going to multiply, this can be done, 2 by 2. This will be a 2 by 1. So the answer will be a 2 by 1. Okay, now I'm going to multiply 5/3 times negative 3 will give us negative 15 over 3. Negative 2/3 times negative 5, times 5 will give us negative 10 over 3. We add them, this is what we get. That's the answer for the first part. Now I'm going to use the second row. So I'm going to multiply negative 1/3 times negative 3 and add it to 1/3 times 5. So here we go. Negative 1/3 times negative 3 will give us 3 over 3, which will be 1. 1/3 times 5 will give us 5/3. If we add them, it's going to give us 8/3. So that's my solution. This is my x, this is my y. Okay. Now this is the last problem for this for today. This is how do we use the application of matrices, right? It says write a system of equations and use the inverse of the coefficient matrix to solve the system. This is, we're going to apply this word problem by using the method on the previous slide. The solution, right? This is first, right? Let's read it together. The budget truck rental charge $19.99 per day plus 59 cents per mile to rent a 12-foot moving truck in Austin, Texas in 2016. The total bill for your move was $86. The rates for a local moving company were $10 per day and 95 cents per mile. And the bill for the same trip, number of miles in the same day and the same number of days, would have been $94.10. How many miles and how many days was the trip? Okay. So x equals to number of days, right? And y equals to the miles driven. So here we go. We need to get two equations. So it's going to be 19, right? We're going to use the 1999, the 0.59, which is 59 cents, and the bill was 86. There's my first equation. 19.9x plus 0.59y equals to 86. And for my second equation, we're going to use the 10, the 0.95, and the 94.10. So it's going to give us 10x plus 0.95y equals to 94.10. Right, so we're going to use the same method as before. The A will be 19.99, 0.59, 10, and 0.95. The X will just be X and Y, and the B will be 86, 94, and 94.10. So we need to get the inverse of A. Here, guys, we can use the calculator. Okay, so if we put this in the calculator and just hit the inverse key, this is what it will give us for the inverse. Round it off to 3 places. Now we're going to multiply by B. And again, we're going to multiply 0.073 times 86 and negative 0.045 times 94.10. Well, if we do all that, guys, right, then this will be my answer, 2 and 78. So 2 days and 78 miles was the trip. Okay, I believe this is it for this PowerPoint. Thank you for staying like 5 minutes extra. And if you have any questions, let me go back to the main screen and perhaps you can ask questions. Thank you, guys. Thank you for staying a little bit extra.
Next week, we will have for Math 1314 basic matrix operations and using matrix operations. For Math 1324 sets, and for the Student Success, Pulse Radio, and Eureka Club. Thanks so much to Mr. Alberto Isasi for presenting today. Thank you to the audience for coming and being a wonderful audience, and we hope to see you again soon. Thanks.